My name is David Hetzlam. I'm the Executive Director at Earth Advantage, and I want to welcome everybody here tonight for this event where we're going to talk about the path forward for net zero homes. And first, before we get into a discussion with my colleagues, I wanted to thank Greenhammer for hosting the event here. Woo-hoo. And also thank Ninkasi Brewing for providing the beer over at the beverage table. Thank you very much. So the panel here tonight really represents some history around this topic and also, part of the future, I would say, around this topic as well. So starting on my left-hand side, Taylor Watkins is here tonight. And Taylor is not only an appraiser who has specialized in understanding the value of green buildings and energy efficiency in buildings, he also has been intimately involved in those buildings because he has a ADU in the backyard of his property that was built to be a net zero house. What year was that, Taylor? In 2004. And so Taylor actually put some sweat equity into that as well. I think some of the passive solar mass in that floor was installed by you.
And I believe you put some work into that house as well?
That when I was before I came to Earth Advantage, I had my own contracting company called Coho Construction Services, and we were the general contractor on that project. And it was a really exciting project. And our next panelist, Charlie Stevens, actually helped on that project as well, because at that time Charlie was with the Oregon Department of Energy, and they had a pilot program to try and get some net zero homes built around the state. And so this was one of the first two, wasn't that? That ADU in Taylor's backyard. And then there was another house at the coast at the same time. So, but now Charlie works at NEA, the Northwest Energy Efficiency Alliance. And he's still doing the same kind of great work because now Charlie is really pushing at, it's called the Next Step home, right? So a home that's beyond what we normally think of what might be an energy efficient home right now. Charlie's created a specification for what that Next Step home looks like. And he's trying to drive specifications for where we could take efficient housing envelopes in the next 5 years or so? Right. Yeah. So really great to have both of you guys here tonight for the conversation.
I should add one thing. My colleague Christopher Diamond, who worked at the Oregon Department of Energy and worked even more than I did on the house we're all talking about, comes to work at NEA with me on this project on Monday.
Oh, that's great news. Yeah. Thanks, Charlie. And then on my right hand is Stefan Aguirre with Greenhammer. Stefan is the president and founder of Greenhammer. And Greenhammer has been doing a lot of great building since 2003? 2002? Oh, you just had your 10-year anniversary. That's right. Hanging right up there. If I could do math, basic math, I would be on that. So, and Stefan's company was an early adopter of passive house modeling and practices when those came to the Northwest, and has been a big proponent of those, and has built some really great projects, and I'm sure has some other great projects on the board right now.
Yeah, I pretty much picked up where you left off. So.
Great. So we're going to go through a few questions and have the panelists handle those. But before we get into that, I did want to just put a shout out for a couple Earth Advantage things. One is that we have a class called the Sustainable Homes Professional class, which is actually the reason I left my company and came to work at Earth Advantage, because I really liked teaching and I wanted to go to Earth Advantage and teach the Sustainable Homes Professional class. Stefan now teaches that class for Earth Advantage. And we have our next round of that coming up in later this month, right?
Yeah, it's a really incredible course. Actually, I think I wouldn't be teaching it otherwise. And it's not because of me. It's because it really is actually, the information is pretty fantastic. But, so.
Yeah, and it's a Friday, Saturday, once a month for 6 months. Mm-hmm. And the whole purpose of it is for you to learn the best practices of green building, whether that's energy efficiency, health, resources, water efficiency. And it's very, very practical, where you actually have, it's a hands-on experience. You bring a project to the class over that 6-month period. You evolve that with what you learn in the class. So whether you're a contractor or a designer or some other professional in a related field, it really is something that you can take what you learn in that class and put it to work in your daily life. So we're pretty excited about that. At the end of this, if you want to ask some more questions about it, Stefan and some Earth Advantage staff will be available to talk about that. And then one other thing to talk about, given our theme here about net zero energy homes, is that last year Earth Advantage started a certification standard for net zero homes. And we've had, correct me if I'm wrong, Ryan, but we have one home that's been certified so far to this very tough standard?
There's 2 in bed and there's 1 more going.
Okay, so 2 done, another one on the way. And Ryan Shanahan, standing over there, he just spoke. He can tell you more about that net zero standard if you're interested, and you have some flyers here too, Ryan?
We brought flyers, they're also next to the SHP flyers.
Okay.
And the one thing I'd love to add is that as of this year, we now have a net zero ready certification as well.
Great, so that's like all the shell measures that you would do, everything except the PV.
Exactly.
Right? Okay. So a builder might be able to get it to that point, and then the homeowner could get the PV installed in any way, shape, or form they saw fit. Okay, great. All right. Well, that's all the introductions. So what we really want to talk about tonight is how do we get net zero homes to be mainstream now? I mean, what's it going to take from a policy standpoint, a technological standpoint, until this is just what we're doing? You might know in California, they actually passed a law that says by 2020, all new homes there need to be net zero, which I think now they've been spending a lot of time backpedaling on what the definition of net zero might be. But they did pass a law saying that, you know, that's what new homes by 2020 have to be there. But they might not quite be there for a bunch of reasons. What we want to talk about is how do we get to that point? And before I get into that, I just want to go back to how did we get to this point historically where we could talk about having every home be a net zero home potentially, and what policies and technological leaps had to happen for that to take place. Because I'll tell you, when I got really jazzed about green building was when I was still in college, and daydreaming in my chemistry class or something like that about building some great green building. And what you would think about back then was, oh, it's going to be off the grid, it'll have solar panels all off on the roof, its own, no power needed from any outside source. And, you would read something like, Home Power magazine and fill your head with these ideas of how that would happen. And then you needed all these batteries and all this kind of stuff to make it happen. So you never really thought of that happening in a house that was tied to the main grid in an urban environment until they started making grid tie inverters that made it easy for excess power coming off your system to just go right back onto the grid. Now, Charlie probably knows better than me, but the first I know about that is they were getting installed in about 2001. And then there was a standard that came out in maybe 2005 that made it a lot more practicable for that to take place. So even though we were putting some in before 2005, then a standard came along that made it easier for them to be manufactured to that standard. So that was a technology, until you had a grid tie inverter, you couldn't really think about having a net zero house. Like that didn't even really come to be thought of. And then policy-wise, it wasn't really going to be very feasible until there were some policies with the utilities in place that was going to allow them to allow you to connect your grid tie inverter back to the grid, and maybe just as importantly, pay you some way, shape, or form for putting that surplus power back onto the grid. So those policy changes had to happen at state public utility commission levels. Oftentimes it was tied into the deregulation that was kind of happening at the same time. But that was a policy level decision that had to be made at state government level that allowed us to even have these grid-tied inverters, which had come onto the scene, get utilized out in the field. So historically, those are a couple examples of technology and policy that had to develop and evolve together in order for us to even talk about a house being a net zero house. So now, going forward, you know, what do we think, and I'm going to put this out to the group right now, you know, what do we think the next policy changes are that need to happen for net zero homes to become the standard? Now, I'm going to throw one off the table, which is the state comes and says every single house has to be net zero by 2020, or 2021, or 2022, because that one's just a little too easy. So, but there have to be just some key policy things that could take place at the state level, local level, utility level, that would promote us. Panel.
I mean, currently, when incentives, right? I mean, that's like the that's one big piece. You know, tax credits. We right now, I think, you know, from an economic model standpoint, we have highly incentivized solar, photovoltaics. You know, to the point of we're doing a net zero. Hopefully, it'll, you know, designing for a net zero 6-unit community on 25th and Ankeny, and you know, we look at the metrics for that, and we get a, you know, it's the RETC, so we have the 50%, you know, tax credit up to, it's like $6,000 per unit, and then we have a 30% no limit federal tax credit, and then we have a dollar, I think, contribution per watt for PGE. And, you know, you take a $5, of course the market's changing a little bit, maybe more cost competitive now, but let's just say $5 per watt, you know, in the residential sector is pretty standard these days. It's coming down a little bit. But you end up, all those incentives equate to somewhere around like getting you down to like $1.30, $1.40, $1.36, I think, or something a watt. And that's, it's interesting because, you know, when I look at how we can conserve energy on the building, we do much better on the insulation and the, well, in particular, the air sealing. But the incentives on a, just aren't there outside of, you know, some Energy Trust of Oregon incentives for performance, but you stop, we stop at a point somewhere around, you know, $3,600, $4,000 on a per unit basis on the really the insulation and air sealing measures, and unless you really start dancing around and some tricks, and that's, there's a massive difference there. And we have about a 4-to-1 payback on the envelope and the air sealing that we do on the photovoltaics. And, you know, if the RETC follows the BETC, which is no longer around, the business energy tax credit for photovoltaics, what's going to fill the void? Is something going to fill the void? Because there's a, if that goes away, then net zero becomes that much more distant for us to achieve. So all this PV work actually does help a lot because it makes up that last little bit. But if you want to do a net zero building, as anyone who's ever done a net zero building before, you spend a lot more on the air sealing insulation, and maybe, you know, we're figuring out maybe the most optimal ventilation for net zero is kind of one of the projects. But we spend more right now on the ventilation systems. We also believe in good, comfortable air quality. But, you know, I think we need to start considering federal and state tax credits that are equivalent, that really are focusing on the best bang for, best kilowatt for the dollar. And there needs to be probably a fair amount of research results because it's easy to invest in kilowatts on a photovoltaic panel.
Or maybe they should treat every kilowatt the same.
Yeah.
Because, because right now what you're saying is, you know, a $20,000 PV system that around here might put out up to 5,000 kilowatt hours a year
Yep.
is getting, you know, $13,000 in incentives.
At least.
Yeah.
Yep.
And if, you know, the measures that you might put into the shell of the building that might save the same,
Or 3 times or 4 times as much.
yeah,
Basically the same dollars.
aren't
you
getting
know.
anywhere near the same level of incentive.
I'm saying for $20,000 spent on the envelope and air sealing, you're likely to get 4 times the you know,
Incentive
the
level.
incentive level. I mean, the kilowatt savings.
So having
3 to 4.
So having incentives treat every kilowatt hour the same would be a good change.
Yes.
Okay.
Then the question is, can you hear me? Yeah. All right. So then what is the solution then? I mean, well, actually to back up, to ask a larger question, I guess, of the panel, how realistic is it to expect any incentives to stay in this market around construction of energy efficient buildings, period? If it seems from where I sit in the job I do, it seems likely that we can expect incentives to go away in large part. So then what can we do as folks in even a space that has little incentive at all? Also, we're talking about incentives for PV, for example, that aren't exactly market driven either. Also, from where I sit, I'm at a different end of the spectrum from a lot of you, is that would any residential PV be installed, period, if there weren't incentives? And I think the answer is no. They're too expensive. And so if we created a system, well, I guess what I'm saying is, have we created a system that we can't fix at this point? Or what are some avenues that maybe you see on the policy side for redirecting what limited tax credits or incentives we have into a place where the public and builders, the buying public and the building public can actually use the money to better effect?
I think I'm probably going to end up being the policy guy here on the panel because I have about 25 years of experience with that. But I think people need some context, and I'll add some here to give people an idea of the landscape we're all working in that some of you may or may not know about. First of all, there is competition for residential PV generation that might be associated with a net zero building, and that is that today, if you are a utility or a large investor, you can put a large, 100 megawatt solar project in the field for quite a lot less than $3 a watt, with no incentives. So the price is coming down substantially on large scale. So, the question is, if you want to invest in solar PV generation, where do you do that? Do you do it on a house-by-house basis, or do you do these large-scale things on a piece of land out in, eastern Oregon? There are constraints out there, to be sure, because these things need transmission that they don't have. They need shaping from the existing grid, shaping services because they only deliver during the day, of course. Shaping is what we use in the Pacific Northwest, the hydro system, to do our shaping. Basically, when you have wind power, solar power, any kind of resource that's intermittent and may not be entirely predictable, it has to be shaped to the demand on the grid at that moment.
To match the load.
Right. From minute to minute, everything has to be shaped to match the load. And, you know, if the wind starts to die out in the next 30 minutes over in eastern Oregon, well, something has to be brought online to fill that hole. If an hour later the wind comes back, well, now you've got to back off on something if you're going to take the wind. So there's this constant shaping of the grid inputs that goes on, and if you're an intermittent resource, you have to pay to have your input shaped by everybody else who's feeding the grid. And in the Northwest, we feed the grid in a shaping fashion with hydro. That being said, we have limitations in the hydro system because in the springtime, we have an enormous amount of water coming off the mountains out here. We cannot spill it because if you spill it, you kill salmon smolts. You over-oxygenate the water. It has to be run through the turbines. When that happens, you end up with things like wind power, and during the day, if it's windy, solar power as well. You might be, if you're an owner of solar power, the justifiable market price that you could charge might be negative 2 cents a kilowatt hour. You might have to pay to put your power on the grid because there's too much. At certain times, there's too much. We have to generate power through the turbines because we can't spill all the water and we can't keep it behind the dam. It has to go down the river. So we have these issues that happen that have to be dealt with by the larger grid. In Germany, they invested massively in subsidized power, you know, and you know, we can argue about the merits of that, but they ultimately, very quickly, in about 7 years, got 25% of their power from solar. And what that did is it reduced the peak power price in Germany to the baseload price. So now there is no such thing, essentially, in Germany as peak. It's all baseload. If you look at the load in Germany matched to the demand, it's flat across the middle of the day, and it was 25% of the total contribution of power that flattened the demand curve essentially all the way across the day. And then when the solar goes down, so do the commercial and industrial loads. So residential solar contributes during the day, typically, because you know your power load goes down during the day in a typical household. It goes up in commercial and industrial buildings. So what you're doing with your PV array on the house is you're feeding commercial and industrial. You know, you go to work and your house is powering your computer essentially at work. So that's kind of the paradigm on the grid, and have everything be economically viable. It can't displace everything, and we've got all this hydro that we still have to use. There's a lot of other factors that go along with this. Years and years and years ago, the Oregon Department of Energy did a study of what the solar access was for houses in Oregon. And they found out that less than half of the houses in Oregon really had good solar access. And that was for solar thermal, and it's even worse for solar PV because you really don't want to shade anything on a PV array where a little shade on a thermal array system doesn't really hurt it that much. But the fact is that I live in a forest. I live in an oak forest along with all my neighbors, and we're not going to cut down all of our trees. And if you're going to build houses there, we need the trees too. We need the shade. So that there's this other question of, you know, where is the best place to put all the solar? Is it house by house by house? I don't know. City of Ellensburg, which is an unregulated municipal utility, both gas and electric, they have a program for community solar where they put the solar out by the interstate. They provide the intertie, they provide the ground equipment, and the community citizens buy panels. And every month you get a credit on your bill based on how many of the panels you own. So they can do that because they're unregulated.
But that's an example of a local policy that they put in place at the local government level, which...
The local utility.
But is it not a muni?
It's a muni, but the utility essentially put that policy in place. In Oregon, that's illegal. Okay? So one of the better ways you might think of, and if I live in my neighborhood and I don't want to cut down all my trees, but I want to have some solar contribution and I want to be net zero, I would like to be able to, say, join a co-op and have the co-op buy the panels and manage the contracts for the rooftops or whatever, and I just buy the panels, and then I get a little credit on my bill, and I can invest and be net zero. In Oregon right now, it's illegal for something like a co-op to aggregate solar at multiple meters. It all has to be done at 1 meter. That's a problem. So that's a policy thing that would allow sort of a net zero thing to occur. Regardless of what other investments we make in the buildings, it would allow us to get the solar wherever it makes sense, 100, 200, 300 kW at a time on the top of a Walmart or a Les Schwab or whatever, and I can invest.
All of Swan Island, basically.
Yeah, all of Swan Island. Yeah, I mean we have occupied the landscape everywhere. So anyway, there's some context there that you have to think about as you understand what net zero means. And I'm focused, like these folks are, on the buildings to make them essentially the power consumption really low. And the last thing I'll mention, based on some of my recent research, is that just like the indoor air quality in a home, as Stefan I know understands, and I know Dave understands this too, depends not only on the building and what you've built the building of, but it depends also on the furniture you brought in and what people bring into this building after you build it for them. Things off-gas, you know. Things produce nasty things if you buy the wrong stuff. And it's hard to know what the right stuff is sometimes. Well, the same thing is true when it comes to energy. You can make the building really, really, really energy efficient and then fill it full of guzzling, really, truly guzzling appliances. You know, we've discovered that
people.
Or people, yeah. So, you know, we've discovered that, for instance, the average clothes dryer uses over 1,100 kilowatt hours a year in one of our recent studies. That's huge. That's probably more than lighting at this time. It's more than anything except space heating and water heating, pretty much. So all of a sudden, it's like, whoa, you know, how do you get to net zero if you've built a house and 40% of the total consumption is the house and everything that Stefan and Dave and Taylor knew how to promote, and then you fill it full of stuff that uses enormous amounts of energy. I mean, so it's a problem.
So at the state level, could large-scale solar, large-scale PV be promoted, say, from the governor's office in mandates for percentage of production statewide in renewables?
Yes. If it was owned by a group of investors or a utility on a single site, absolutely. And I think you'll see the governor promoting that based on his most recent energy plan. They definitely are moving in that direction.
So instead of a co-op, we need to form an LLC.
Well, no, it's actually illegal for an LLC to aggregate meters as well. The problem isn't the form of ownership, it's the aggregation of meters.
One quick question here.
My question goes a little bit back to the idea of the incentive and what is the benefit that the state receives from incentives so that we can kind of get an idea of what is a good payback from the state's perspective of rebating solar versus insulation. It's kind of just a general thing so that I can see what
I think that's a better question for you, Charlie. I mean, the benefit of the state.
I don't want to do all the talking here.
Well, the benefit, I mean, on the Energy Trust incentives, the benefit for them is they have to supply savings. Like their mandate for existence is that they must supply cost-effective savings into the marketplace. So for every dollar they provide into the market, they need to provide so many dollars of energy savings back. For the state, it meets more of a policy goal. If the state has decided our policy is that we want to promote so much renewable energy production in this state or so much energy efficiency, reducing our overall load in our state. In my understanding, it simply is a policy goal of the state, and that's the benefit they gain from offering residential energy tax credits to homeowners.
Well, the state may very well look at it that way, and I believe they do, because they're not, quite frankly, very forward-thinking, and I don't think they understand the economics here. There's a fellow named Bob Wise who works for Kogan Owens Kogan here downtown, and he's in the process of doing a number of studies of where the dollars leak out of our economy. And so far he's done 2 studies. One of them is energy and the other one's food. The amount of money that leaks out of our economy from the energy sector is about $8.5 billion a year. Now, some of that is oil related. This is Oregon, yeah. So it's about $8 billion, $8.5 billion a year leaves the state because we don't have oil wells, we don't have natural gas, we don't have coal, we don't have any of these inherent energy resources. We do have hydro, we do have what wind we have, and we have some energy resources.
A lot of wave energy.
Yeah, we're working on that. The energy's there. We haven't tapped all of it yet. But anyway, the fact is we don't have a lot of the energy resources that we use. And in fact, an enormous amount of capital leaves our economy every year through that channel. And so in theory, if the state was actually enlightened enough to think about it, they would actually understand that if you could keep even a quarter of that, say $500 million a year, here in the economy, and I'm saying a quarter of the $2 billion or so that might be related to the energy savings in buildings that we're all talking about here, natural gas and some of the electricity, in other words, our economy, the state's economy and our employment and a whole lot of other things would be a whole lot more prosperous if we could keep that money here.
Because there'd be a multiplier effect if that money stayed here and went to
Yes.
local businesses here.
Absolutely.
Somewhere around a 3 times multiplier effect. So you might be able to, the local economy might grow by $1 billion if you weren't exporting that out of the state.
Right.
Yeah, there's a mitigation too. I mean, there's a less tangible mitigation of what happens when you have peak related issues, the costs that actually are associated with that, and of course any environmental costs and things. But one other thought I had when you were talking a second ago, Charlie, was just about zoning, and when there's a lot of energy waste in the systems. Certain buildings need to exhaust heat. Others need to heat, and so some buildings are producing all of that heat and dissipating it into the atmosphere, and others are trying to conserve their heat. And data centers, right, being like I was just walking in the Dalles a few weeks ago, and I'm walking along by Google, and I'm seeing the really inefficient buildings with heat pumps and things, and I just consider in certain areas when there a regulation around what can be next to what. And I'm looking at these inefficient buildings producing heat, and then this massive building exhausting heat adjacent. And it's like a district heat system is a no-brainer. And part of that, in that particular case, it's just kind of a no-brainer, and I'm not sure, for me, from energy, when I see something like that, if you're like really master planning a development, would that make sense? There are some complications there, and some losses, but there's absolutely some coupling that could happen, and in a city area. We were talking about net zero as one area. We're also just, what about energy conservation or energy distribution? And I think there could be certain regulations, particularly around zoning, that allows adjacencies and grid certain, like, especially in heat and water in particular.
And so that's part of like the eco district concept, is how you could be sharing energy usage around a whole area rather than thinking about it building by building.
Yeah, well, in most sorry.
I just have a follow-up to that question on a much wider scale, kind of addressing Charlie, but really to any of the panelists. Charlie, do you think there's any way that the shaping issues could be mitigated by wheeling, even intermediate wheeling agreements? Years ago, I worked for Pacific Cogeneration,
There are a few holes in the transmission system that are in the process of being filled, plugged. But again, this is a system. We have two problems: the market and the system. And the system is not designed right now, nor is the market designed right now to actually accommodate these things. So what you see is in Stefan's case, he's walking around Google, and yep, there's a hell of a lot of heat being generated in all those servers, and you know, Facebook and everybody else over there, and you know, in the middle of nowhere. There's a reason why they're in the middle of nowhere, and you can't take advantage of their waste heat, and that is because it's really cheap. Okay, the power prices over there are way better. The taxes over there are way better. The cost of development over there is way better. I mean, you know, by the time you add up the upfront cost savings of putting it in the middle of nowhere instead of sticking it in the middle of downtown Portland where you could use the heat, not going to happen.
Yeah, that's where I was going.
You had like the classic European scenario where they would have put greenhouses next to it so they could have been doing some year-round agriculture from.
Right. I mean, you know, and you know, we could maybe retrofit that at some point. But
And that would be an example of technology which I have to move us over to, because we spend a lot of time talking about policy.
Yeah.
And I, you know, the
How
other
boring.
It's bit,
Sorry.
Well, so this is more of a, maybe a, so what if instead of subsidizing energy, we subsidized the end product? So instead of, because maybe then the market would bring the cost of the energy savings down, but what if you, for example, sold tax credits to financial institutions to give lower mortgage rates to businesses and residential properties that had a certain, and it could be a tiered system, so maybe you have 3 tiers or whatever. So they could get a lower rate, and then you could have competition among the financial institutions for those tax credits, as well as increase the competition among the energy organizations because they're not getting the subsidies anymore. I read an analysis not very long ago, and I really can't remember where I read it because I read a lot of junk, but they were talking about how perhaps energy subsidies are keeping the cost artificially high because solar in particular is much cheaper in a lot of places than it is in the United States. So I guess I'm curious about that, if that's ever something that you've heard of being explored. And my other question is, what about SDCs, and is it very common for that to be an area of subsidy?
On the first part, I haven't heard of a larger sort of business side or production side tiered system like you're talking about. And I do want to backtrack a little and say that I'm not a completely free marketeer type of person. I was a little bit playing slightly devil's advocate to try to get to what you're talking about now, is how do we make energy more valuable to people, or make actors in the market more aware of the value of energy? Because a lot of times in the basic home transaction, it's not emphasized at all. And something similar to what you're talking about has been introduced in the Senate by Senator Bennett from Colorado, called Sensible Accounting for the Value of Energy. The SAVE Act. What's that? The SAVE Act. The SAVE Act was actually named the SAVE Act before it was an act. The Institute for Market Transformation came out with it. The idea is that one of the largest expenses for owning a home, unless it's a net zero home, would be energy. So, but our mortgages cover principal, interest, taxes, and insurance, all of which, some of which, like taxes and insurance, are less than people pay for the energy of their home. And what don't you know when you go to buy a house? You have an inspector look at everything in the property, health and safety issues, all these sorts of things, and you have no idea what it's going to cost your family to occupy that home. And that is the primary benefit of a net zero home, right? And so the idea with the SAVE Act, which you all might want to email your senator about is that the debt to income ratio, when they're figuring out what kind of mortgage you can afford, will include your basic energy expense for occupying that home. So they will raise your debt limit according to how much energy the home will consume or not consume. So you can borrow more and even get a more favorable rate on your loan if you can show your home uses less energy than a comparable home. So that's one way where people actually buying these places that we want to build more of can actually get some value directly out of it. The other thing that Dave has worked on tirelessly for years is energy performance labeling on homes. Again, to just bring awareness to people in the market of the value of the energy that they're consuming in that house. And one of the reasons energy performance labeling, it's my opinion, hasn't taken off in different parts of the United States is the huge amount of pushback from the National Association of Realtors on it. Any sort of number attached to something on a home they feel will devalue the home, rather than emphasize or promote value for homes that have better scores on energy. Yes.
You know, I'm kind of curious, is that, I always find it interesting that it's just a point rather than a range. Because you're just talking about, you know, 60% of the energy use being by the occupant use inside, 40% the other. So wouldn't it be more realistic to look at a range?
Yes.
Because you may have one occupant, you may have 6, and that's going to make a big difference.
I think it will, and oh, sorry, go ahead.
Well, I was going to say that then it would give people a better idea when they purchase the house, depending on the size, and also some kind of a guide. What are you bringing into this house? You know, to give them a sense. To me, that would be more accurate because it's a little misleading just to say this building scores at this point, but you don't know who the previous occupants were.
That's true, and I will hand it off to Dave in just a second after a comment on the difference between occupational and asset ratings for homes and what the difference is, and it kind of it speaks to what you're talking about. But the one reason for an energy performance label with a particular number on it is tied in with the SAVE Act. You have to have some kind of more absolute number than a range if you're going to make a more direct comparison between homes, and you make a more direct comparison between homes with an asset rating.
Yeah, and really what you're saying when you say this house is going to use, 20,000 kilowatt hours worth of energy this year is you're saying generally there's a range of what it might use that's going to be somewhat of a normal curve, and we're saying that's the middle. Because at the middle, you have 2.2 people living in this, 3-bedroom house. That's what the average is if you look at all the data out there, not last person's utility bills, but that's what it would be for the average occupancy of this building. So therefore, that's what the financial markets care about. They don't care who exactly is living in that building at this moment in time. The financial markets care about what does the average occupancy of this building look like. And that's actually over all the buildings out there. That's what the utility markets care about. What does it look like on a normal distribution? Let's see it there. As long as it's a normal distribution, you get some strange characteristics going on, they might care about it. But that's how we look at it from the asset. It's the normal occupation of this building would put it at this point. Now that allows us to compare this house to what this house could be under other conditions, and therefore free up some money to spend on making it that improved condition without ever getting any incentive money involved in the picture at all, potentially, if you could free up the money to reward the fact that this is a more efficient building. I really want to talk about technology. Stefan wants to say one more thing, so I'm going to let him.
Well, I guess I'm thinking about a lot of different things. We're talking a bit about, the carrot side, and we're in the carrot phase of energy, right? And the stick's coming. And that's, that's a reality to some extent. We know that code isn't going to decrease its energy requirements. We know that. And we know that we're also getting stuck in the details a little bit, because a net zero building, whether it's actually netting zero or it's positively generating or it's just under, is a massive and completely different building than a standard building that's out there that we all are going to go home to tonight, most of us anyway. And there's an incredible difference. And they're all just leaking right now. All these buildings are just energy dissipators, big time. And there are things that we can do on the policy side to improve buildings. The generation of course, district energy or statewide policies, national policies, or municipal systems are always going to have a better effect on the energy grid, always have a better potential for the energy grid. Like anything we can do shared is probably likely much better than to do in an individual home. However, homes leak a lot of energy. So really it's the leakage that's in my mind, that's a big, big problem, leading into maybe technology here a little bit. And leakage is really the biggest opportunity that I would see. Putting the PV on the homes at $5 versus $3, and incentivizing that by $4 and change is a little bit asinine, and from a policy standpoint. So I think that needs to change. That's kind of the root of what I was starting at the beginning, is that I'm going to benefit on our projects having cheap photovoltaics, because the sticks are coming. And the sticks come in all kinds of forms. The sticks come in forms of climate change. The sticks are coming in forms of code regulation and in other states that are already saying net zero energy is a requirement. And these requirements are coming because our population is growing, and people love Oregon, actually. So we're really growing. And that means more people, that 8 billion just is going to increase, right? That dollars out the door just continues to increase. And those dollars are going out literally our doors and our windows and our walls, in particular our attics and floor systems. And so I think, we have to understand fundamentally where we are now and where net zero is a massive shift. We got really involved with Passive House because there was a Canadian and American geekdom about 40 years ago, 50 years ago, that really kind of this super insulation, air tightness, and ventilation strategy. Like let's do that. That makes a lot of sense. There's got to be a point of optimal conservation, and Amory Lovins and other folks postulated, like Wolfgang Feist and the postulated that, well, there's a point where there's got to be cost effectiveness here, right? Where you invest in these air tightness strategies and these ventilation strategies and everything else, where you stop your divesting in your mechanical systems. And ultimately, they got to this point where they said Passive House. Okay, well, maybe that's the perfect point. Maybe it's not the perfect point. The bottom line is that building those buildings, as we've got more and more experience and more of the industry's picking up on that, it's incredible that for 10% more construction costs, that we can reduce energy consumption by 80, 90%. That's pretty incredible from just an insulation and air sealing measures, and especially when you compare that against the cost of photovoltaics to make that kind of a drop. And that's where our technology is going, and it's going in these systems. And where would be really fantastic was actually, from a policy standpoint for net zero energy, I think we can kickstart with carrot. Ultimately, the stick's going to come, and we're going to move in this direction anyway. I would love to see actually the manufacturing incentives, because I'm a big proponent of the multiplier effect. And all of the wonderful air sealing technologies that we have, not all, there are some liquid applied materials, but a lot of the stuff that we like to use, because we like to use stuff that's really minimizing toxins and process and everything else. So the closer it is to a natural product, typically, the downstream and upstream and everything effects are just better. So all of that stuff's made in Switzerland and Germany and Japan, and and you know, the heat pump systems, you know, the best heat pump systems in the world, like, you know, Carrier's great, but it's not as good as Mitsubishi or Daikin. There's like, you know, our windows and doors, we're so leagues and generations behind what's going on elsewhere.
So you're saying, why can't we make that here?
Yeah.
Before we leave policy, I just wanted to add on the ratings, we're working on that. Dave's working on that. We're working on that. But I would remind people that 85% of our energy in homes problem is in existing homes.
That is a good segue, Charlie, because talking about technology, I was going to take the easy conversation off the table because you have your next step home specification for new homes. Stefan has passive house for new homes. Either one of those is basically saying, hey, with a new home, it's not that hard to get this building really energy efficient. So there's a whole lot of houses that are already out there. How is the way, you know, what technology is going to help us get those homes to this really high level of performance? You know, what do we have right now that we're using to upgrade those homes, or what's going to come down the pike very soon to upgrade those homes? So this could be, I mean, this also opens up mechanical question a little bit more because it may not be as feasible to at such a low cost to upgrade the shell of these existing buildings. So now maybe we might need to depend on some mechanical systems that on new construction doesn't matter as much once you've reduced the load almost to nothing. But so what do we need to be looking for to take all these houses that are out there that are using a lot of energy and help bring those down? Because you're right. I mean, that's where the biggest problem we face is.
Yeah, I mean, the nail on the head. On the mechanical system, it's a lot easier to put a condensing, you know, washer dryer unit in than to wrap the building in foam or rock wool, you know, rock wool. It's a lot easier to put in a, you know, what is it, the Sunfrost refrigerator, as opposed to, you know, putting in triple pane, you know, tilt turn.
And you're speaking from
windows.
experience.
Yep.
Yeah.
And it's a lot easier to put in mini split heat pump systems, you know, than ground source, of course, and some other things. What is and will be and needs to come down the pike is really around water. That's one of the, I think we're satiated a little bit on the mechanical side, relatively speaking, to years past. You know, in Oregon, with the climates that we have to deal with in Oregon, anyway. But air-to-water heat pumps, I think, is a big technology shift for Oregon, not necessarily the world, because it exists all over the place.
And but we're talking about really efficient ones, like the current ones that are on the market that might be performing around 200% efficient, or
yep.
210 or 220.
And not only that, so there's a few
it's
things.
Not as efficient. I mean, you're talking about getting something
before
twice
I get
as
Charlie
efficient
in,
as
because he's gonna trump everything. But there's a few things. CO2 heat pump systems is, of course, a technology. I'm on the heating and cooling side. We're getting coefficients of a performance of, you know, maybe 10 or 11, arguably.
Only when it's warm.
Yeah. Okay, much better. Possibly 3 times what we're getting with standard refrigerants. There, you know, if those types of systems, we have air-to-water heat pumps we can put in garages, which is actually, if you're out in the suburbs, maybe a really wise transfer if it's a really well-sealed garage, because you can actually get some heat transfer from the engine. But you know what we aren't able to have, and what's actually really complicates the systems, is, you know, they bump out a lot of cold air, and they attach these units to the hot water tank. They're pumping out cold air, and you put that in a building. We've actually put them inside of a passive house building. We really are interested to see how that, you know, how between the communication between that and its mini split heat pump. But, and you know, if we actually could put those compressor units outside the building like we do with mini split heat pumps, and which happens in many places all over the world. Daikin Altherma makes the world's most amazing one, but I don't, you know, it's too great. I can do too many amazing things with it. It cost me $20,000. So, you know, if we had simple, you know, air-to-water heat pump systems that were cost-effective for just standard domestic hot water, which we don't really have in the United States. That's a technology shift that will come shortly that I see, and the CO2 refrigerant will come, and those things will be good things in Oregon, in my opinion. But I'm really interested to hear what Charlie has to say there. The last thing I want to point out is the heat recovery ventilation. And Charlie's doing NEA's doing a study right now on ventilation effectiveness and efficiencies, and he can tell you a lot more about it. But we're a big believer in fresh air in a building coming from a place that you plan it to come from. From an energy standpoint, it may not necessarily be the best thing, but from an air quality standpoint, I really like to do, especially in a really tight building that we produce, to put into bedrooms continuous fresh air, so heat recovery ventilation systems. And efficient systems like the Zehnder, which is a Swiss system, Zehnder. So Zehnder, we're getting heat transfer efficiencies in the upper 90 percentile, and just the ability to transfer heat from, the cold air is coming in and exhausting the outdoor air, pulling that air, that temperature out, or allowing the heat to dump into the air efficiently, providing continuous fresh air. Manufacturing a system like that in the United States would be fantastic. I'd love to see more of those. And ventilation ducting through systems. And the beauty of the Zehnder, we spend all this money on shipping it, a lot of money, most of the money actually in some cases, shipping these units. But when we get them, we still buy them because their ducting is so smart. They're polyethylene pipes. And those polyethylene pipes fit right within a 2x4 studded wall, and we can retrofit those in. And on a retrofit for a fully integrated ventilation system, on an existing house, because we're able to pretty successfully, tighten old 1920s buildings down to, air changes per hour of less than 3. That's really tight for an existing house. And at that point, it gets to a point where you lock air in these bedrooms, and I don't like that. Even if you have a bathroom fan going, it may not be pulling from my bedroom, so I get a lot of CO2 in that room, and I don't sleep as well, and, whatever, I come in here all stressed out. And
So I want to quickly hear Charlie's response on that. What I heard from Stefan was heat pumps.
Yep.
Especially high-efficiency heat pumps that use CO2 as refrigerant.
Yeah.
And then making sure that you have a good ventilation system.
Yes.
Okay, all right.
He's right. Stefan's right.
Okay, there we go.
We're working at NEA on a lot of these things. We have a huge heat pump water heater program that we're working on we're actually writing the specifications for those things so that we get what we need. Ones that will exhaust to the outdoors after they cool the air. You can buy those now. They're expensive, relatively speaking. We're also, the problem is what you're going to see here in all of these systems is a house is a system. And when you're working on a system, you have to remember how everything interacts. And Stefan is doing a really good job in passive houses especially, and then the houses he builds, of reducing the loads down so small that it's really hard to justify spending an enormous amount of money for that little bit of load that's left. I mean, people are always saying, what's the payback? Well, now, if you had a house that was leaky as could be and was old and everything else, well, wow, you increase the efficiency of the system, the savings are huge. So you can justify the added expense. But once you've got almost no load, it better be cheap. So now we get into what Stefan was referring to earlier, was eliminating things, simplifying things. And so what we're trying to do now, what we've discovered in applying these technologies recently, and I'm working on one of these on Bainbridge Island right now, is that the problem is not so much the efficiency of the system. We're getting annual efficiencies on these systems of between 300 and 350% on a typical ductless heat pump system. The CO2 heat pump system that we're working with right now will probably be between 450 and 500% efficient, COP of 4.5 to 5, which is very good. So we've got these things coming. The problem is distribution. The problem in the building is how do you get the little bit of heat you need to the spaces? That's proving to be a big problem. And it turns out that if you get the load small enough, like you do in a passive house, the HRV can actually do the distribution, but you can't do it with most of the HRVs that are sold in North America. That's why I had to go to Europe to get the Zender systems in here a few years back. And that one will do it, but if you don't invest a lot of money in that, it won't work. The Zender delivers supply air that's about 1.5 degrees cooler than the exhausting air when it's 20 degrees outside. Most, it's 5 or 6 degrees different. And that's the better ones. The average one on the market in the US, you'll see a 7 or 8 degree temperature difference between what's going out and what's going in. That's not going to help you in the bedrooms. It's going to make the bedrooms 58 degrees. So what we're finding is that we have to not only get fresh air to the bedrooms, but we have to get a little bit of heat to the bedrooms because, you know, there's windows in there and those lose energy, and there's heat loss in these rooms. And the problem is really distributing the heat. And it's that system that costs a fair amount of money, and it's that system we have to figure out how to be more clever about.
Especially in older buildings.
Especially in older buildings. You know, if you do it really well, you might have a ductless heat pump in a single zone and then distribute from there. But we're finding that in a lot of cases, the loads are big enough that we actually have to have multiple indoor units, which of course adds cost. And we're trying to get away from cost to meet these tiny little loads that are left. And in a way that's acceptable to consumers. There's a lot of people who don't like that wart on the wall from the ductless heat pump. So we're hiding them in some systems, and that can be done. There are different kinds of, some people just don't like blowing air. They don't want any blowing air that they can feel. So, you know, it's hydronic. Well, get out your wallet, you know, so.
And Charlie, I know you're very familiar with the air generated heat pump water heaters, and we've now met the tier 2 spec with those, but how do we exhaust them out? And explain to people that heat pump water heater is taking the air in the building to heat the water, and then they think, but I just heated that water, I just paid, or pardon me, I just heated that air, I just paid PGE to heat that air. What? It's going in my water? We have a lot of issues there where we need to educate, and I think that, you know, what Steph has done past HouseNet, there's only so many Oregonians that are doing it for, I hope I don't offend anyone, Mother Earth, and then there's a lot of Oregonians that are doing this to save money, and we don't speak to both parties at once about when we market as a distributor. You know, all my marketing is how does the homeowner save money, and then we do a poor job of telling them why they must use the system the way it's designed.
I think that's an excellent, it's an excellent segue to just this last topic we were going to talk about, which is, you know, how does the real estate market value an energy efficient building, you know, a net zero building? Because what you were just talking about is, I'm talking to building owners about saving their utility bills. Like that's what the value of this work represents. Charlie was talking about payback periods, which is just doing a little bit more math with that, right? Like what's the installed cost, what's the utility bill savings? But neither one of those takes into account the fact that, hey, maybe my building is actually worth more as a building because it's more efficient. It has better mechanical equipment than it did when it had the old 80% furnace in there and a shell that hadn't been upgraded. And then that changes the math because now they're spending money to improve their building, not just to lower their utility bills, but because now their building is worth more than it would be otherwise. And this is something that Taylor could probably speak to as an appraiser. That's kind of Taylor's job, is to help establish what the value of a building is. And he is constrained by what the willingness to pay of people in the market is, and we have a pretty much illiterate population in terms of what the value of energy is. But I think Taylor could talk to you a little bit about what, how appraisers look at the value of a building, because this is really a missing link. Because if all you ever concern yourself with is the incremental savings on the utility bills, and that's all this is worth, and you don't count the fact that now your building could actually be worth more, then it changes the math. So,
Yes, it changes everything. The first thing I'll say is I'm a residential appraiser. On the commercial side, when you're dealing with net operating income, utilities, water, and electrical savings, it's a much different animal. And that is the reason that there's so much more retrofitting going on the commercial side than there is
because if
in
you
the
lower your
residential side.
utility bills on the commercial side,
Then your income rises.
and then if your income is higher from the building,
You have more value.
so your building is worth more.
So
Very
on the
simple math.
residential side, though, which is the reason earlier I was talking about some sort of performance metric to make people more aware of what their behavior is doing to their bottom line. I think it will influence people's buying decisions. There are several different ways you could value a performance label of some sort. It's not just helping a buyer make a decision, or it's also making it easier for someone like myself to track what people are actually willing to pay for an incremental difference in efficiency. Right now, it's far more difficult. And I would say in certain areas, close in Portland, it's clear that people are willing to pay a little bit more for a more efficient home. Suburban areas, it is not clear. And it can vary from neighborhood to neighborhood. Okay, so it depends on the type of buyer, typical buyer for that property. Okay, my job isn't to figure out what one person would pay for that house. My job is to evaluate what 6 out of 10 of the typical buyers for a house like that would be willing to pay. And that's based on market data that is out there. But here's the tricky part. If I don't know what net zero means, if I have no idea how the shell of this home is different from the other homes I'm looking at, there is no possible way I can judge the build quality of that home. And most appraisers know nothing about how a home is put together. The reason they know the differences between properties is because they have been inside literally thousands of them. Okay, so I've been in over 4,300 different homes in the greater Portland area in the last 22 years or so. And I talked to other appraisers about this. So how do you know that one home is superior to the other? Well, I went inside one, the kitchen's been remodeled. I go inside the other one, the kitchen hasn't been remodeled, therefore this one is better. Then it's my job to take that qualitative judgment and quantify it in some way. And I use that by comparing sales of homes with these different characteristics. And I can extract differences like square footage, garages, all those kinds of things. And whatever is left is probably what that kitchen difference is attributable to that kitchen difference. But what's happening now is a high-performance home is built differently than a code home. What I know about all those code homes is they're 2x6, bat insulation, 16-inch on center. They have OSB, some kind of house wrap, and some fiber cement siding on it. Okay, well, in a high-performance home, it's probably different, and the systems are different, but I can't see them. All right, so it's not just that appraisers are more aware. It's buyers and sellers are more aware. Realtors who are marketing these homes as different than the other home they're looking at down the street need to know more. The lenders that are lending on these properties need to know more about them. The entire stream, or everyone involved in the home, especially if it's going to be sold, have to understand the differences between that property and adequately speak to them so that people understand the value. Now, all of us up here, we know the value in it, but not everyone out there does. So it's really sort of our job in these small gatherings where we're preaching to the choir to actually go out there and educate other people.
Saying that the inefficiency of the owner is often one of the problems
And-
with the system.
Oh, absolutely.
And that we also need to, because we did a survey of people who bought some homes that we had built that were green, and they were very dissatisfied with their systems. The reason that they were was they did things like put carpet over radiant heat floors. You know, so I think by doing things like incorporating smart house technology, I mean, a lot of these systems, the average person is never really going to figure out how to optimally use that system. And so you need to add in a system that they can rely on so that they are getting their money's worth out of a system that's there. And you may be talking about 3 or 4 owners down the road and not the one who installed it to begin with.
Yeah, you know, I think I just, my instant reaction was education and information. I mean, the reality is things are changing. So I don't care, you know, if you know how to run a furnace thermostat, but you can't click the 3 buttons on the remote yet, because that's going to change. I mean, it ultimately it has to change, but it's our responsibility in the industry and to facilitate that change. And you know, I would say from a policy standpoint, you know, green building certification systems, right, and energy certification systems are all about how you pull the industry to where it needs to go, right? It's not just that out of the goodness of Earth Advantage's heart or out of the goodness of the United States Green Building Council's heart that they existed to increase the standards. It's because, well, really there's money for it, because we know that we need to stop leaking energy everywhere, because we don't produce all the energy we need in the United States, right? So, but we lose it all here. So how can we put a cap on it, so to speak, right? And you know, if one thing that we have to do in the green building certifications world is we have to do homeowners manuals. Typically, for a LEED project, I have to do a homeowners manual. It's really smart. They have to read it. Well, they have to read it. That's true.
They'll read it when something goes wrong.
Yeah, they'll read it when something goes wrong, which is also valuable and true.
That's with the best practices
Yeah,
sheets that we give out in the Douglas workshop.
yeah.
Same thing, the technician reads it if there's a problem.
Yeah, it's still these things are still critical pieces that we don't do the standard, that we don't even have that information. A lot of these buildings are created and handed off, and there's just nothing. Or they're the owner's manual sitting on the architect's or the computer, or in the construction manager's file folder. But it maybe never. Not only was it never given, but it was never walked through and discussed. And here's how you use it. Let's really and then the check-ins. There's no requirement for me to go back and follow up with my clients to see how they're using their building and utilizing energy. And then on the information side, and I think education is huge. We do not, and in the United States, we do not invest in education, period, enough. I mean, that's just like, it's hands down, a big hole. I mean, what a great way to teach a physics class to, in thermodynamics and laws of thermodynamics to students is to walk them through heat losses and thermal flows through a building, right? And from an information standpoint, we all know that the miles per gallon was such an enormous impact on our, consumer choices on vehicles, and the, energy performance score is such an incredible potential for, information, like kind of almost the nutrition label, right, of a building. Is the green building standards that we have out there, right? And we're just starting to get that stuff on our MLS listings. We're starting to use the EPS in other parts of the country, and maybe now it's kind of maybe starting to happen here. But the last thing I really wanted to drive home is that there's policy, and that I think from a policy standpoint, education would be the number one thing. I mean, Jimmy Carter said, "Put on a sweater," right? But he was right. And it's like, put air in your tires. Yeah, Put air in your tires and put on a sweater. Yeah, those are probably the smartest things we could do, the easiest, simplest things we can do to save energy. And it's funny because I grew up with my parents, put on a sweater, put on a sweater, and no one says put on a sweater anymore. Everyone says put in a heat pump and put it, or whatever. Sweater is a lot less expensive, but it's education, I think, and information, and sometimes we get a little bit caught on some pretty complicated details.
Yeah. I was going to touch on one thing in regards to, you don't have to go back and track how people are operating the house. And one thing about the net zero certification that we were putting together was actually, talking about having to supply at the end of a year, like what was the actual energy usage of the building. So that there would be that requirement to check back in. Ryan, you had wanted to say something?
Can I lead it really quick? Because and I want Taylor to really address this. I just want to let you know from a builder's perspective, you're right. At about 2,500 square feet, the cost per square foot, by the way, goes like this. And then at around, you start, sorry, I guess I should go in reverse. From a cost per square foot, we start with small buildings way up here, right? And then we start dropping like this. And then at around 2,500 square feet, it just goes, it just drops off the charts. And when you get to 3,000, 4,000, it continues to just drop. People talk about cost per square foot and like, oh, 150 and 140. And well, yeah, if I build a big enough building, my cost per square foot just plummets. And it's like magic, just plummets off the charts. But my ADUs and, of course, things like that, they are incredibly expensive on a cost per square foot. But we all have to talk about, the magical ADU that's the same cost per square foot as the McMansion. And it's just not a reality. They all have one kitchen and one sewer, one, X amount of bathrooms. That starts to change maybe. But, the infrastructure costs are all the same. And you talked a little bit, I wanted to address the SDC question. But, we do incentivize in Portland SDCs for the additional dwelling units. That's about the only thing we can do to help make that cost per square foot equate a little bit to the marketplace by limiting that $15,000. If we could figure out that there is a payback for the city on the energy side for eliminating SDCs, there might be a merit there. But I just wanted to say that there's this interesting metric, and it's not ironic that at that point is where the average construction is in the U.S. and in Oregon. So
yeah, I think someone's on my keyboard. I think I talk to realtors and appraisers a lot, and I always tell realtors, don't refer to price per square foot. And they're talking about sold price per square foot. And this is where the big problem is. Built price or cost, hard cost per square foot, we never see on the other end. It's already built. It's sales price, so it doesn't really matter. But realtors get stuck on, this home, cheapest in the neighborhood at $100 a square foot, but it figures in land and all this other stuff. So it's a number that is rendered meaningless by the way most realtors locally use it. So if you ever see a realtor who's talking about price per square foot, if they're all identical homes with identical lots in the same neighborhood or something, you might have something. But think about it this way, 2,000 square foot homes. One is on a half acre with a view, and the other is on a traditional lot with nothing special. They'll have completely different costs per square foot because the one is more valuable because of the land. Okay, so cost per square foot, I couldn't agree more, is really difficult. Another way to think about it is, if it's just the cost per square foot, the hard cost for building the home, if it costs more, it's probably a better house.
Yeah.
But if you don't know, again, how a home is put together, you won't be able to discern if there's a difference in the build quality of the house. Now, it's not always the case. Now there are a lot of builders out here also. The other thing that I always say to builders is there is a relationship of cost to value. Cost can be more than value. It can be equal to, or it can be less than value. Okay? Just because it costs more doesn't mean it's worth more. But I totally agree. The cost per square foot, try to get all your brokers and everybody away from that.
Remember
the
what
ductless
was,
is going to have less noise than
Yeah.
your refrigerator.
you actually won't even know it's there, but remember what somebody said earlier about all the products we really need aren't made here?
And unfortunately, that
It's
one
true.
was. It was Trane, or it was Carrier, or it was Lennox.
Well, and it gets back to what you were talking about, you know, in terms of incentive for manufacturing, because you know, you look at Windows, perfect example. Yeah. You look at Germany, you look at Canada, and you look at the U.S. I mean, you don't want to go. I mean, German windows, I've seen them; they're beautiful. I mean, someone mentioned they ship like a rock safe, you know.
Yeah.
But the problem is that you know you get long lead items. If something goes wrong, you've got to get a part or whatever. Canada seems to
And it's $80,000 for a window package for a 1,600 square foot house. Too.
And so, I mean, the alternative is to go to Canada, or the incentive to get manufacturers here to produce.
Well, Europe's actually answering some of that problem, but it's still. I mean, you know, we're getting at $60 a square foot on that side, but you know, only 60, only 60. But however, you know, it's interesting because we're paying similar prices for U.S.-made wood windows that are like, you know, basically wasting 4 or 5 times as much energy, and they don't have all of the great frills and everything else. So it's curious where that money goes when you have labor unions in Europe that are able to produce a much better product with much lower cost. So I don't understand how that works, how that metric is working, because the economics aren't that different.
Well, I think
You want me to go to the marketing question?
yes. The
Okay.
question Taylor still didn't get to answer that
The,
question. I think this actually has to be our last question for the overall group because we're running out of time.
What I would stick with and what seems to be effective is getting away from the features of these houses and into their benefits. Is the home healthier for the occupants? Does it have, through having superior indoor air quality? Rather than talking about the HRV, talk about what that does for the occupants of the home. Is it a healthier home? Is it more comfortable? Is it safer? Is it less costly for your family to operate? Those are the sorts of things that speak to the average home buyer. Look, we're all in real estate. We talk about this stuff all the time. Typical people, they might buy 1 or 2 houses in their lifetime, so they're coming to it with fresh eyes. So, and the great thing about high performance or green building is it does have multiple benefits. So if you can speak to those and sort of tell the story of the house and get away from specifications, I think you'll be more successful.
So I want to thank everybody for coming tonight and participating in the conversation. I expressly want to, mostly thank the members of the panel up here. Thanks for staying around in your own building for a while, Stefan.
I'm normally here anyway.
Thank you, Charlie. Thank you, Taylor. And again, if you want to talk about the SHP class a little bit afterwards, we can find a place over in the corner to talk about that. And
Definitely a few of my best students are here.
yeah, some alumni can talk to you about it as well. And a lot of that class gets to the root of these issues of how you create a really high-performing home, whether it's net zero or not. But net zero becomes kind of a focal point in the class as a sort of the spot that you're trying to get to with these homes, whether it's a new house that you're designing, what do we have to do to get there, or if it's an existing building. So thanks again very much. Hope to see you soon.